Welcome to the Crazy Hat Chemist. So here we go, another video on gases. Bam! So we're going to derive the ideal gas law. And I know you've been waiting for this all your life to derive the ideal gas law. Of course you have. So right here we have Boyle's law, Charles' law, and Avogadro's law. And you notice here that I have on each one of these, Boyle's law, volume is proportional to 1 over pressure. Charles' law, volume is proportional to temperature. Avogadro's law, volume is proportional to number of moles of gas, that's N, and other things are being held constant in those. Okay, combining these together, we get volume is proportional to Nt, which is in the numerator from the Charles and Avogadro's law, and then the pressure from Boyle's law is in the denominator. Isn't that super cool? I love that. We're not done yet, of course. Okay, so V is proportional to R Tn over P. And this R is going to be called a proportionality constant. So now it's called a proportionality constant. Now we're going to rearrange this and do PV equals nRT. The R is still the proportionality constant, which is the gas constant. T is the temperature, and it must be in Kelvin, like I had mentioned before. So there you go, the derivation of the ideal gas law. So a couple other little notes about the ideal gas law. The ideal gas law is a good approximation. Okay, it's not perfect, because I'm going to show you in some later on videos that there's another equation that's beyond, that's using the ideal gas law, but has some correction factors in there. Okay, there are some assumptions of the ideal gas law. So number one, the molecules of an ideal gas do not interact with one another. That is, there are no intermolecular forces. And number two, the combined volume of the molecules is much smaller than the volume of that the gas occupy. That is, the molecules take no space in the container itself. Okay, so given these two assumptions, then the ideal gas law is an excellent approximation of what is actually occurring, or the mathematics of what you ever solve for, whether it's the volume, the temperature, the pressure, the amount of gas. All that holds true. Now, the ideal gas law works under two very specific conditions. That is, it works under low pressure and high temperatures really well. Once you change that low pressure and high temperature to high pressures or low temperatures, or remove one of those from those set of parameters, then the ideal gas law doesn't work as well. And again, we're going to talk about that here in just a little bit, but not today. That is another video to watch. Okay, I hope you enjoyed that video. I am the Crazy Hat Chemist, and I don't know if you ever saw that movie with Tom Hanks, but this is my version of it. Hey Wilson, where are you? Give me a thumbs up if you like that video. Subscribe to my YouTube channel, and I'm going to see you next time for more cool chemistry problems.